Okay, as we were saying, to determine if it's a circuit or a path, you have to look at the vertices, the dots, okay? And more specifically, you have to look at each vertex, right? How many lines are connected to it? So like, okay, at that vertex, see how there's two lines? There's two edges connected to it. So this vertex has a degree of 2. That's what this is called, the degree. Okay? The degree is 2, meaning that 2 roads attached to it. All right? So this one up there is 2. How about this one here? This point here, well, there's one road there, there's one road there, and there's one road there, right? So you have 3 different roads attached to this point, so that means that has a degree of 3. Okay? So you have to identify the degree for each vertex. So this one has 3. There's 3 roads attached to that point. Same thing with this one. This one has 3, right? This one here has 3 also. This one up here only has 2. This one in the middle has 1, 2, 3, 4, has 6. All right? 6. So that's the first step, to write down all the degrees of each point. Now, if you think about it, in order to navigate through each point and come out of it cleanly and not have to go back through that point, it would need to have an even number at its degree, right? Wouldn't it need to be even? Because if it were even, right, like these corners with 2s, that means you could go into the point and you could flow out of it. And then we don't have to ever go back to that point. So we don't have to retrace over it, right? The trouble comes when you have ones with odd degrees, like this one here. See this one? Okay, so we go into the point, we go out of the point, but then we're eventually going to have to come back into the point. We're going to have to hit this road again eventually, right? So we're going to wind up getting stuck there because it's got an odd degree. It doesn't have, for every road into it, it doesn't have a road out of it when it's odd, okay? So the odds give us trouble. So here's the rules. To be a circuit, you must have all vertices must be even degrees. They all have to be. Okay? So, like this middle one here was a circuit, right? This one, I'm just going to erase this real quick. This was a circuit. Why? Because look at all the degrees. So this one has 2, this one has 2, this one has 2, this one has 2. This middle one has 1, 2, 3, has 4 connected to it. See how they're all even? 2, 2, 2, 2, and 4? That's a circuit. Okay? So circuit the requirement for a circuit is that all the vertices have to be even degrees. Okay? And then for a path, you have to have all evens except you're allowed to have 2 that are odd. In fact, you have to have exactly 2. Exactly 2 vertices must be odd in degree. Okay? If you only have 1 that's odd in degree, it won't work because you'll get stuck somewhere. If you have 3 that's odd in degree, it won't work. You need to have exactly 2 points that are odd in degree. They have odd degrees. Okay, so like let's just examine this first one we did here. We said this was a path, right? Well, let's check it. So like, okay, that has 3, right? This one has 4. This one has 4. This one has 3. This middle one has 4, right? So if you notice, it's got all evens except 2 odds, which makes it a path. All right, so I want you to try, easy assignment today, just these 4 right here, A, B, C, and D. A, B, C, and D, and number 1, determine if it's a circuit, a path, or neither.